Okay, hello again. Once again with the start of a new videos series regarding the CCNA, the Cisco CCNA 200-301 new exam that was published in 2020, this year actually. This is Ajar Gafuri once again from the Triple I channel for networking. We have just finished last week the official CCNA English course and complete English course completely for free, completely with 7 chapters built 100% based on the official blueprints of Cisco, and also it contains almost 85 videos with 29 hours, and all of it are organized in a single playlist called the complete English course, okay, alongside with the slides of all the 7 chapters. So after the series was ended, in the final video I had made a suggestion or like a vote asking people that what's next. It's either to be or to I'm sorry, it's either to produce a new course for making an engineer more qualified by practicing a lot more complicated labs and building a new series that's called the mega labs, or you can start then by building, or I'm sorry, by recording or producing another series of videos, which is the exam preparation, which is preparing you for the exam. What might you face in the exam? What type of questions? What questions? Maybe how to solve them. Think about them. Some notes that you need to know, you need to be aware of, so that it will aid you a lot or help you a lot in passing the exam from the first attempt, and also with high confidence. This is extremely important to be confident in the exam so that you would complete all of the questions without any fear or anxiety or getting confused or whatever. Okay, so the votes actually were almost like 9 or 10 votes only on that video on the past 5 or 6 days. Most of them, like, they were like 6 to 3 votes for the exam preparation. To start with the exam preparation, I will make the mega lab series later, of course, after I finish this series of videos. This series of videos will be only about like 5 videos, okay, because of what's coming right now. The new exam, the 800-301, is actually made of currently the candidates that are experiencing the exam and trying this online exam are seeing almost 100 questions. Comparing with the old exam, it was like from 50 to 60, 65 questions in the old CCNA 201 to 5. The new 2020 CCNA, which has the code of 200-301, are showing almost 100 questions, and by almost I mean some people are seeing 101, others are seeing 102 or 103, and so on. This range we can see like from maybe 95 to 105 such. So this is the an approximate number of questions that you might face the exam. Why the exam questions were almost doubled and it's still giving you the same amount of time, which is 120 minutes if you are a native English person, and an extra 30 minutes if you are not a native English person. So it's 2 hours for English people and 2 hours and 30 minutes or 2 hours and a half for non-English people who are preparing for, I'm sorry, for are taking the exam or experiencing this same exam. So using the same amount of time for the old exam and the new exam, but in the new exam the amount of questions were almost doubled from 50 something to 100 something. How come and how could that be enough in time? It will be because of what Cisco done, which is in the old exam you were to see 4 different type of questions. The majority of the questions were called the multi-choice questions, the MCQ, where you have a question with 4 possible answers and you need to choose one of the answers. That's it. You will not type anything, you will not use your keyboard, and maybe even if you're like you have forgot the question but you know a bit of it, just by seeing the just by seeing the choices that you have, you might refresh your mind and remember the correct question and choose it. So that was number 1, and that was almost like 60 or 65% of the questions of the exam questions. Type number 2 of the exam questions were called drag and drops, and we will see them in this video also, like MCQs. Drag and drops are like some possibilities on the right side, left side, with a correct or corresponding answer to them on the right side, and you need to drag using your mouse a question or a possible answer from the left to its correct box on the right. That's it. That was also called drag and drops. It had high mark points, or had high point weights before, like maybe more than even 10 points per each question of drag and drops, and they are still showing right now in the new exam. So basically, by comparison between the old exam and the new one, both the exams had MCQs, both the exam had D&D, drag and drops. Type number 3 of questions in the old exam were called like an evaluation question, where you will have a lab with routers, switches, servers, and PCs, and multi-layer switches, and you can access those devices and hit some show commands with no configure, only show commands. So you can like show version, show run, show IP interface brief, show IP OSPF neighbors, show IP IGRP neighbor, show IP OSPF database, show BGP neighbors, or show BGP summaries, show IP NAT translations, show IP NAT maybe statistics, etc. Okay, show IP DHCP binding and show IP DHCP database, all on, and so on. I'm sorry. So all of these commands, you will be using them to show information from inside these devices to answer 4 questions, 4 MCQs. So you'll have like MCQ number 1 used to say what prevents having an OSPF peer between R1 and R2. So then you'll have to go to R1 and R2 and make some troubleshooting by clicking on both the routers, do some showing commands and answering that question. That was called the evaluation exam. Right now it has been removed. For now, so far, for all the candidates that has been joining the exam in last of Feb, March, and now the beginning of April, all of them are not seeing any evaluation exam at all, because actually at minimum it might take up to 30 minutes for one question from you, for each evaluation question from your time. And type number 4 in the previous exam was called the lab or the simulate, where you have a real lab. Like you'll have a complete lab with the initial config, OSPF or AIGRP, some servers, routers, and switches, and end devices, I'm sorry, like PCs. And in the end, there will be some tasks. Configure an access list to prevent PCs from accessing server number 1. Find another access, create another access list for another thing. Make a new OSPF peer for area 1 for PC number 1 and 2, or maybe network number 1, and so on. So there will be tasks and config, and maybe you'll get a misconfigured lab and saying that correct it. Make BGP get peered, make OSPF peers. So you'll have to delete the old OSPF peers which were misconfigured, and then you configure a new and fresh and correct OSPF peers, which is also right now has been removed. So no keyboard, no simulates, no evaluation questions, no labs, none at all. You will get almost 100 questions of theoretical questions so far, like only multi-choice questions and drag and drops. This is what's happening so far in April, from Feb, March, and April so far in 2020. So this new series of exam questions or exam preparations, we will discuss and work and try to solve whatever type of questions that you might face in the real exam, in the real 203 exam. Might not be sure, because Cisco will change those questions perhaps every day, but this will give you a good idea regarding this. So you have a complete course to study, and you'll have another series of videos that's called the Mega Lab for highly practical labs, or some complicated labs that will take hours from you to solve for each lab, and then the series of the exam preparation to prepare yourself for the exam and what might you face in the exam to make you take your exam and pass it confidently. Okay, so let's start with the questions. Actually, your exam 20301, as I said, is, I believe in my region it costs almost $200. In specific way it's $195 so far, and I have heard news that the exam cost might be variable. I'm not sure, but I heard that some people are finding the exam with the cost of almost $300, just like the old one. But for me, I've tried to book the exam for myself twice, and both the time it only asked for $195. so you can check it yourself from the pearsonview.com's website. Also, the exam has a complete score points of 1000 point to pass. I'm sorry, to pass the exam you will need 825 points to pass the exam. So it's the minimum amount of points that you need to score to pass. If you scored 825, you will pass. If you scored 824, then unfortunately you will fail. Okay, you have to retake the exam in about 1 week minimum duration of time after that you have failed the first attempt. So that's why I'm making all those series of videos so that no one will fail. All of you will study correctly and practice correctly and also prepare correctly so that you will pass the exam from the first attempt. So without further discussion, let's start with reviewing some of the questions that my friends, my colleagues, a lot of people that I know from the networking world suggested that you might face these questions in the real exam. So let's prepare for them and let's see if all of those questions or most of them, half of them, some of them were mentioned in that course that I have made before, and see how beneficial that course was. Okay, so starting with question number 1, and that will be refer to the exhibit, which is this photo right here. It's about a topology, and there is only one router which is called R1, and inside R1, as you can see, someone typed the command of show IP route. Show IP route. This is some shortcuts for typing show IP route to see the routing table of this router and how can this router see the internet and see the entire private network of this company. Okay, so refer to the exhibit. This is the exhibit. Which type of route does R1 use to reach host 10.10.13.10? So 10.10.13.10, which is this PC right here. Which route, or maybe I'm sorry, which type of route does the R1 use? Okay, option number 1, a default route. Option number 2, network route. A network route is like advertising a network using either OSPF or static route or maybe any other dynamic route that we haven't learned in the exam. But you should not face any GRP, BGP or ISIS. You should only face OSPF and static, since they were only the two protocols that were mentioned in the blueprints. A host route will be like routing to a specific host with a subnet mask of 32 instead of a complete network with subnet mask of 24, or a floating static route. So let's see the options down here. And the options are like what we can see is that this is a generic route which is 10.0.0/0/8. This is as class A subnet. You can leave it for now, you can ignore it, but let's see which of these routes can reach 10.10.13.10. so the first one will be C, which is directly connected. It can reach 10.10.10.0/30. So 10.10.10.0/30/30 actually is called a point-to-point subnet, which gives you only 4 IP addresses inside it. The first one will be a network ID, the last one will be a broadcast ID, and only these 2 IP addresses are valid to use. So what I mean by that is that using the connected route we can reach 10.10.10.1 IP and 10.10.10.2 IP address. What actually we are facing is another or complete different subnet, which is 10.10.13. So it's not from these ranges at all. So this one cannot be. Okay. Option number 2 will be O, and this stands for OSPF. OSPF can reach 10.10.13.0/25. Okay, good. Let's try to see if this one is useful or not, because it can reach using OSPF the subnet of 10.10.13.0/25. Okay, so /25 gives you, after doing some subnetting that I've talked about in chapter 1, it can gives you almost 128 IP address starting from .0 and up to 10.10.13.1 to 7. So mine is 10.10.13.10, which is from this range, and saying /32 meaning that it's a host route. But let's see if this one is good. This is a probability actually, because yes, your route can reach 10.10.13.10, this PC in here, using OSPF, using this option. This is a probability, but let's see the other options. Number 3, C, which is connected, it can reach 10.10.10.16/30. Again, /30 gives you only 2 IP addresses, and since /16 is there, so /17 and 18 are inside it, so no, definitely not. Okay, and we can use some sort of logic, and I will tell you what that logic is. C is actually refers only for the directly connected cables or directly connected devices to this router. Who is directly connected here is the cloud, the internet, which is definitely what we are not talking about, okay, because we are trying to reach this one and there is no other cable, okay. The other directly connected cable is this one, which has already its IP addresses, so there is already a broadcast domain here and another broadcast domain here. So trying to reaching this PC using the connected is impossible, because you need to use a routing protocol to reach this one. So we can already take the C out. Okay, so the fourth option, which will be OSPF, can reach 10.10.13.144/28. /28 gives you 16 IP addresses, and since it starts from 144, then it might end up to 160, and this is of course not the .10 that we are looking for, so this one is not acceptable and it's useless. Okay, and finally B stands for reaching 0000. This is a default route by using BGP. So BGP, which is the protocol that's used here, and how did I know that's used here? Because BGP is used with internet. It's always BGP that it's been used with internet, and using BGP, it's advertising a default route using, this is the administrative distance of internal BGP with a metric of 0, but in all the cases this is leading you to default route, which is to here, to this way. Okay, so it's not mentioning 10.10.13.10. actually only this guy here is mentioning 10.10.10. I'm sorry, .13.10 to be able to reach 10.10.13.10, which is this one. So we can reach 10.10.13.10 using OSPF, and OSPF is advertised here on /25, meaning that it is a network route. Okay, it's not a default route. Default route will reach me to the internet, from the router to the internet, which is this guy here. It's not a host route because OSPF here is used /25 and the host route means /32. So no, it's not /32, definitely not. It's not a floating static because there is already no static route. There is no S mark here at all. Not for static route and not for floating static route. So the correct option will be B for this question. I hope this was clear. Okay, this is question number 1. Question number 2 that you might also face in the exam. Refer to the exhibit again. Which prefix? The term prefix means an IP and its subnet mask. Maybe 10.10.10.10/24. This is a prefix. Okay, so which prefix does router 1 use to reach host A? This is router A1 and this is host A. This is just like the previous questions with a bit of differentiation using the IP addresses. And yes, you will face a lot of similar questions in the exam. So if you are good and have good skills like in this subject, then all of these questions you will guarantee its score. Okay, so which prefix will router R1 use to reach host A? Option number 1, router R1 will use 10.10.10.0/28, or let's see, the routing table would be better because there is also show IP route here. All of these options in the first are B. All of these stands for the BGP. So this is talking about the internet. I will not use them. Okay, and there is also some C, C, and C here. This is for the directly connected. I'm sure that I will not use these. Why? Because this router already has a network here from these 2 points and another different broadcast domain here. So this is directly connected. This one is not directly connected. There is an IP address here making this is a broadcast domain and this is a different broadcast domain. So it will not be directly connected. Definitely I will need to use a routing protocol. It's either to be OSPF, all of these O's, one of them might be good, or the static. So let's see. So it's 10.10.13.214. By using OSPF, it either will be option number one. Sorry. Okay, so option number one, which is this one, that would be 10.10.13.0/25. 10.10.13.0/25, just like I've mentioned a few minutes ago. /25 gives 128 IP addresses, and it's a 10.10.13.0. So starting from 0 up to 10.10.13.127. No, because it's 214. Okay, so it's beyond this network. Leave it. Option number two says 10.10.13.128 as an ID, the first IP address, with a subnet mask of 28. Subnet mask of 28 gives you 4 zeros in the subnet mask, 28 ones and 4 zeros. So number 2 to the power of 4, which are the 4 zeros, will gives you 16, number 16. So you'll have only 16 IP addresses valid inside this network. So since this network starts from 10.10.13.128 and it's /28, then this network ends in 10.10.13. You can add 16 here, so that will be 130, 140, 144. So it's something between 128 to 144, yet it does not include our IP address, so no. Okay, and option number 3 will be using 10.10.13.144, also /28. So this starts from 44 and it also have an increment value of 16. So that will be 10.10.13.160. So it's between 144, 160. No, we are 214. Leave it. Okay, option number 4 will be 10.10.13.160/29. 29 gives only 8 IP addresses because it has only 3 zeros in the subnet mask and 29 ones. So 2 to the power of 3, which are the 3 zeros, will be 8. So it starts on 160 and surely will end on 168. No, this is useless. Okay, the last option will be 10, not the last option in the OSPF actually, not there is a static that we might use, but that static is throwing the route to 10.10.11.2, which is here. So this one is definitely useless. Okay, you are my last hope. So 10.10.13.20.208, 10.10.13.208/29. Gives 8 IP addresses. So it's starting from 208 and it will end like in almost 216 or 15 as a broadcast ID, one of them, the same thing, no problem. But the idea is that 214, yes, it finally happened to become in this range because it starts at 208 and ends in almost 215. So 214 is the one that can use, is the route that the router can use to reach this PC. So 10.10.13.208/29, which is this one, is the correct answer for this question. Hope that was good. Hope that was light. Hope that did not take like an hour from us to solve. A drag and drop. The previous 2 questions were multi-choice questions. I have a question, multiple choices. I need to choose one of them or more. Notice that. Okay, let me just give you a note that when there is A, B, C, D, 4 applies always. Actually, I have been like in these are these are 5 certificates. Actually, not 4. One of them was broken. Okay, thankfully, the frame and glass were broken 2 days ago. So these are 5 certificates. They took from me almost 8 exams. There is also the OCSE, the SPNGN1. So I have almost like, with the failed exams, I have almost like 11 or 12 Cisco exam. I have taken like almost from 11, 12 Cisco exams before, online Cisco exams. So I know their method by using the questions. If you have A, B, C, and D choices, then it's about to choose one only one answer to be chosen. If there was A, B, C, D, E, 5 answers, then you will choose 2. If there was A, B, C, D, E, F, 6 answers, then you will choose only 3. And if there was only, it happens very rarely, but it does happen, A, B, C, D, E, F, G, 7 multiple replies, I'm sorry, 7 possible answers, then you will need to choose 4. So in all the cases of Cisco, you will leave 3 incorrect answers and choose the other correct answers, whether it was 1, 2, 3, or 4. So these are the multi-choice questions, and Cisco do always, they are not like other vendors that I have been with. Cisco do always, between 2 brackets here, will tell you that answer 2, answer 3, answer 4, or there was no bracket here for telling you how much to answer, then it's only answer 1. So don't get confused. Don't get confused. This is just a hint for you to note that when you see like 6 answers, then 6 answers, really? I should choose only one? Read the question again, you will see like in 2 brackets in the question like choose 3. Okay, that is a good hint for you. So this is the drag and drop. I need in the exam to drag this question from here and drop it to the correct fact right here. So let's see how we will do that. That will be all these 6 informations, and you are really fortunate that they are 6, because in the exam you might face 8 or 7 possibilities on the left and only 6 boxes on the right. So one of the answers is incorrect. I need to leave it on the left. I need to choose, and then to choose the other correct 6 answers to drag and drop them to the right. So what I'm having right now simply is that I have 6 specifications or 6 informations. They are randomly distributed. 3 of them should be for the FTP, or 3 of them should describe FTP, File Transport Protocol. The other 3 should describe the TFTP, the Trivial File Transport Protocol. Both of these were discussed in Chapter 4. So just in case you watch my course or another course that you have studied FTP with, let's see what we will use. This provides reliability. You know the answer then previously, because just in case you have studied FTP, then you know what does reliability means when loading an iOS image upon boot up. So who does offers reliability? The guy that uses TCP. FTP uses TCP port 20 and 21 for 2 data management channels. TFTP uses UDP 69 because it's unreliable. Okay, so since it's reliable, then it will be FTP. So this is the one. Answer number 2 does not require user authentication. I'm not sure. Let's jump to the next one and leave it to the final possibility. Uses port 69. I've just mentioned that. This is TFTP. Go ahead. Uses port 20 and 21. Oh god, what are you doing? Okay, 2021. So this will be FTP. Go ahead. Uses TCP. This is TCP. Let's be here. And uses UDP. This is UDP. Go here. Okay, so this one have no room but to go for the TFTP, and this is how I do not get confused or anxious in the exam, by giving a bit of patience and waiting for the other answers to be eliminated so that I can see that. So jumping to Chapter number 4 that I have also, I'm sorry, that I have previously discussed FTP there. This will be FTP. Let's clear the screen. There is FTP. This transfer files like software images. This is using TCP 2021 for control and data channel. There is a relative called trivial FTP, uses UDP 69, and it is unreliable. Okay, so I did mention all of that in chapter 4 2 months ago. Okay, so I'm good, and you can answer this question using the information that I have provided you with. Okay, so let's go back. We have answered all of that. Okay, jump into question number 4. Question number 4 says a frame that enters a switch fails. Okay, so there is a switch here, and this switch is like having some interfaces are here, and all of those interfaces are connected to cables, and these cables are going to whatever thing. But what's saying is that there is a frame that was trying to enter this switch through a port, whatever port, and it failed to enter the switch, and there is a frame, and I'm sorry, a switch fails the frame checksum, because this frame, I believe that I did mention in chapter 2 that the frame starts with a header, with a payload, with a frame checksum in the end. Okay, so it failed the frame checksum, check sequence, I'm sorry, just the checksum. Which two interface counters are incremented inside the switch? Interfaces counters are some deeply and detailed physical specifications and information about each and every physical interface or port inside the switch. So these are 4 interfaces, like maybe fast Ethernet 01, 02, 03, and 04. You can use the command of show interface. I'm sorry, this is a T. Show interface. Okay. Fast Ethernet 04 and hit enter. Then you will see a ton of information regarding this port. All of those are regarding this port, so they are physical informations with a bit of MAC address and IP address for this port, but the others are a lot of counters. How many frames that try to enter this port and were failed, any problem with the port itself, maybe the port is corrupted, any problem with the cable, any problem with the cable power, just in case it was a fiber optic, etc. From these information, some of them get incremented every time an error happens, every time a frame fails to enter this port or fails the checksum. Okay, so one of these two counters that do increment in every time that a frame fails are, I'm sorry, these will be the input errors, because this is an input trying to enter here, okay, and the CRC. Okay, these two values will get incremented in every time a frame checksum fails to enter a switch. You can hit the show interface fast Ethernet 04 and see that. Okay, I hope it is okay. Another drag and drop. Okay, so this time drag each IP address to its network. Like we have a network that starts from 172.28.228.1 and ends with 172.28, 229, 254. So this is starting from 172, okay, to 8, 228.1 and ends with 172, 29, 229, 254. So we can see that the distance or the traveling distance or the IP address between these two are almost 512. How did I know that? Because the very first IP address here is the, okay, what did I do? Okay, this is 28, I'm sorry. Okay, these are similar and these are different, so the increment is starting from these two octets and going above to these two octets. So let's see, this starts with 228.1, So it's 228.1, 228.2, 228.3, 4, 5, 6, 7, 8, 9, 10, up to 228.254, and there is more because right after that, if we increased a bit, if we increased only one IP address, it will start with 229.0, 229.1, 229.2, and until we reach 229.254. So this means that here I have incremented almost 254 IP address that made me reach this IP address, and another 254 IP address to reach this IP address. So I've used 254 twice, and that makes it 500 and almost 200. Yes, that will make it almost 508. Yep. With using even these last two, it will be 510. So this means that this network starts from 172, okay, 28, 220, God, 28, 228.0 as a first one, and it has slash 23 because an increment of 510 requires almost, by using the subnetting videos that I've used in chapter 1, and I hope that you did already study it, you did not jump to here directly, then that will be like needing almost 9 zeros on the right, 9 zeros on the right, so 32 minus 9 will give me 23. So this network here can be also expressed using 172.28.228.0/23. That will be okay. So let's see which one of these guys is /23. This one is /23, and this is 172.28.228.144. So yes, this one is in the range of these and this network. So we can say that this is answer number 1 correctly. Okay, so this is for answer number 1. And yes, you will do all this subletting in the exam. Yes, I'm sorry to tell you that, but this is a good place to practice them. Maybe you'll find the same question in the exam. Maybe you'll find a similar one. Maybe you will maybe I did say maybe twice, and this is the third maybe, and I'm coming up with a fifth maybe also. So maybe you will like improve your subnetting skills in this series before you're going to the exam. And let's go to the second network. This one starts with 172.28.224.1 and ends with 172.28.231. Oh god, dot 254. So this will be 172.280.2240.1 and ends with 172.28.231 and the very last IP address of 231, which is 254. So these are similar. Good, it's a class B so far. And starting from 224, 225, 226, 227, 228, 229, 230, 231, 230, 231. 7 octets on the right will kept incrementing until we reach the end of 231. Each single octet contains 254 IP address inside it. So this will be almost like 7 multiplied by 254, and anyone can help here. This will be like 7 multiplied by 250. That will be 1750 plus 7 multiplied by the 4 that I haven't used. 7 multiplied by 4, I forgot. No, I did not. That will be 28. So the increment value is 1728. Oh god, 1778. Okay, so these are the IP addresses, all the IP addresses in between the range of these two networks, and that gives us the subnet mask of 1, 2, 4, 8, 16, 32, 64, want to wait 512 1024, no, 202048. Yes, so I need this line on the right. 0 2 3 4 5 6 7 8 9 10 zeros on the right, so 32-bit minus 10 zeros will give me 22 ones. Is there any 22 here? No, but there is a 21 which is even bigger, so yes, this one does include that. Okay, so 228 with its IP addresses are from this range, so this one matches this one, and you'll have to calculate all of that during the exam. Yes, I'm sorry, but you have to. Okay, so this is the only Cisco exam that you will ever use subnetting with, so you will do a lot of subnetting, and this is something that I've always make use of. Don't worry, in the exam you'll have a paper and a pen. Okay, it will be an erasable board with a color black or a dark color pen that you can use, and you can reclean it again during the exam by having like a special eraser or like a tissue with a water or such thing. I've been in a lot of experiences actually with that. So there will be no calculator. I'm sorry. Yes, Cisco forbids that. Juniper and Huawei do allow for calculator, but not Cisco. So that's what you have to do. You have to do subnetting all the time. So I hope by using these two methods that this was okay, and I will rely on you to complete these three. This one is very simple. This one is extremely simple because 172 is similar, 28 is similar, 228 is similar. It only starts from 129 to 254 only. That's it. So it's like only the amount of IP addresses between number 129 and 254. So let's say that it's from 129 to 254. This means like 254 minus 129, and the amount of IP addresses between them will be 254 minus 129. 254 minus 100 will be 154, 134, 130, 125. Could it be? No, I believe this is not acceptable, but yet I believe it's at 120, almost 125 this way, and going here 128 is good, so take this one on the right. 1 2 3 4 5 6 7 zeros is what you need, so 7 zeros will be like 32 minus 7, that will be slash 25. So one of these networks should be slash 25, this one. So 172 1289 to 250, and yes, this one is from this range and it does have the slash 25. Okay, so we have solved so far three, which are these three actually. The second, third, and fourth, you will need to solve these. Can we solve the slash 28 since it gives only, how many does slash 29 gives? Only 8 IP addresses. So is there anyone here that has a range of only 8 IP addresses? Yes, this one has a range of from 145 to 150. This is even smaller than 8, so this one is useful. Okay, this is will be good. So we have solved 4. This one is here, this one is here, this one is here, this one is here, so that's it. Okay, come here baby. Done. Thank you. I hope you made use of that. Okay, because I did a lot of discussion about the subnetting in complete 5 videos, 2 hours of 5 videos in chapter 1. If you just paid good attention for those videos, it will help you a lot in doing this question in a good way and in a complete way. Okay, so this was question number 5. Actually, I was planning to discuss 25 questions in this video. So far we are almost 45 minutes, so completing in this way. Okay, you can pause the video reaching whatever question you'd like. This is depending on your ability to absorb new information and to understand new questions, because some people can only study 5 questions a day, other can study up to 50 questions a day. I've started with 20, and sometimes I used to reach up to 50. Like, I kept reviewing some old questions from old versions and books and PDFs, etc., and I kept making myself with those, preparing for the exam, because I did complete the course, I did complete the hands-on labs course, so on, and in the past years. So this depends upon your ability. I will try to finish as much as possible. Maybe I will finish all the 25 questions in this video. For you, you should not watch all the video. You can maybe only watch like 5 questions, pause it, and rewatch another 5 in another time. Okay, so question number 6 says, how do TCP and UDP differ in the way that they establish a connection between two endpoints? In chapter 1, that was the first chapter that I have ever produced. I have talked about layer 4 technologies, the transportation technologies of this was layer 2 text, and now we are having layer 1 text, layer 2 text, layer 3, which is IPv4 and IPv6, and layer 4. So TCP is reliable, slow, uses three-way handshake. UDP is not reliable, makes it faster, and there is no pre-steps performed, no prerequisites, and it's connectionless. So this guy on the right is not reliable, very fast, no three-way handshake. The guy on the on the right, the guy on the left is reliable, slow, uses three-way handshake, and is connection oriented. So going back to the question about how do TCP and UDP differs, actually they differs that number one, okay, see there is no choose two, so only I will choose only one answer from these, and that answer will be TCP uses three-way handshake. I've just said that on the slide, and UDP does not guarantee message delivery, not reliable. So that's it, it's correct. But let's just read the other questions, maybe there is a more accurate answer. TCP uses synchronization packets, okay, which is in the three-way handshake. I did explain that in chapter 1. UDP uses acknowledgement packets. No, UDP have no pre-steps performed, so it uses no packets at all. That's it. So this is definitely not. UDP provides reliable. Go ahead. UDP is not reliable. I've just mentioned that. UDP uses SYN. UDP uses nothing, dear. UDP uses nothing. Sends directly. So question number 6 has answer number A. Not A is not a number. Answer A. Okay, the correct answer. Okay, question number 7. Which 802.11 frame type is association response? 802.11 is wireless, and in the wireless chapter have we mentioned the frame types? No, I didn't, but based on some research I believe association response, I believe it's the management frame. I'm almost sure that it will be the management frame is an 802.11 association response frame. Okay, you can even furthermore search that on the internet or using the official book of the official cert guide of Cisco. Okay, so question number 8 will be the pen. In which way does a spine and leaf architecture, this was about finally, okay, let's complete the question before jumping to chapter 1. Architecture allow for scalability in network when additional access ports are required. Okay, so jumping back to chapter 1, sorry, go back few slides to the architecture subject. This is layer 1, even before that, yeah, spine and leaf. Okay, so spine and leaf, what happened? Not me. Okay, so spinal leaf was about a spine, which are the like the distribution switches, and the leaf, which were the access switches. So any access port will be connected directly to a leaf switch. Okay, so it will be directly connected to a leaf layer. All the access devices like endpoints will be like servers and etc., and it will definitely be servers in the data center and in the leaf spinal leaf architecture. All the servers here will access the access layer, the leaf layer, which is called here, by directly being connected to the leaf switch. So going back to the question, and that question was, in which way does a spine and leaf architecture allow for scalability in network when additional access ports are required? If you need more additional access ports, then you need more access devices, and that means more leaf switches. So we need more leaf switches. Let's see the options. Option A spine switch and a leaf switch can be added with redundant connection between them. Why would I add a spine? Unless all the spines were full. Let's see another reply, maybe good. A spine switch can be added with at least 40 gig uplinks. No, because access ports will not be connected to the spine. Access ports will be connected to the leaf. A leaf switch can be added with connections to every spine switch. This is something mandatory in the architecture of spine leaf, and it might be the answer. A leaf switch can be added with a single connection to a core spine switch. No, every single leaf switch will be connected to all the available spines above. Let's see if my diagram was correct or not. This leaf is connected to this spine and this spine. Leaves do not connect together, spines do not connect together, but whenever you add a new leaf, then you will need to directly connect the leaf to all the other spines. So what does I mean, or what does this question mean, I'm sorry, is that you can add a leaf switch and connect this leaf switch directly to all the new spines or the old spines, and this new leaf switch will increase your access port. So answer number C is correct. Question 9 will be, which statement identifies the functionality of virtual machines? Also chapter 1. We are already, so far we are talking almost everything about chapter 1 and the bit question of FTP of chapter 4, but okay. So the hypervisor, which is the one controls everything, communicates on layer 3 without the need to additional resources. Hypervisor communicates on layer 3 without the need for additional resources. Not sure. Each hypervisor can support a single virtual machine and a single software. No. Definitely not. The hypervisor will be responsible for all the virtual machines built in upon it. Okay, all of them. The hypervisor can virtual some physical components like CPU, giving you a virtual CPU, virtual memory, and virtual storage. Definitely, this is the main thing that I've talked about in chapter 1. I'm sorry. Virtualized servers run most efficiently when they are physically connected to a switch that is separate from the hypervisor. No, we can create a vSwitch and we can connect the vSwitch to a virtualized servers and make the hypervisor control them. So no, this one is definitely correct. I'm not sure about this one. I'm sure that these are wrongs. So yes, I will go with C because this is definitely correct regarding what we have talked about and discussed in chapter 1. Okay, that would be good. Question 10. Which command automatically generates an IPv6 address from a specified IPv6 prefix and a MAC of an interface? We did that on a lab in IPv6. I believe we did that on a lab in IPv6 in chapter 1. And just in case we did not, what you need to do is that you initiate your pack tracer, establish a router, and to go to one of these interfaces in a router, and inside the interface you will hit the command of IPv6 enable, and that's it. You will create a new IPv6. Okay, so some other versions do use another type of command, or I'm sorry, another command to create the modified EUI 64. This is, I'm talking about in this question is about the link local. Just in case you have studied IPv6, then you will know that I'm talking about the link local IP address, which is an IP address that is extracted from your MAC address, from the interface's MAC address, because each port in the router has a separated or a unique MAC address. So taking this MAC address in a link local EUI 64 modified equation will gives you a link local IPv6 address. But the question here, which command should I type inside the port to generate this link local? Number one will be IPv6 IPv6 address DHCP. We are not talking about a DHCP at all. This is no DHCPv6. Hitting IPv6 address with this address. Actually, I wanted to generate an IPv6 address. I'm not typing an address here. I want the router to generate one. If I already have one, that I will not need to generate anything. IPv6 address autoconfig. This is the replacement for IPv6 enable. So this is definitely correct. And also IPv6 address. This address link local. Okay, I know it's a link local, but link local should be automatically auto generated. Okay, I should not type it by myself. Okay, so answer number C will be correct for generating a link local EUI modified 64 or modified EUI 64. Okay, so question 11 will be, when configuring IPv6 on an interface, which two IPv6 multicast groups are joined? Okay, so going back to chapter 1, just in case you did study chapter 1, and heading to some layer 3 technologies like the IPv6. My friend, IPv6 is here. There are some examples or types which are 2000 ::/3 is a public. This is not a multicast. This one is unique local. Okay, so this is not a multicast, this is a private. And this one is a multicast. So we need to choose some multicast groups like FF00::/8 IPv6 addresses to join the multicast. So let's go back to the question. Okay, and that will be definitely not you, not to the 2000, not to 2002, not the FC, DDC2. Am I sure that this was a DDC2? Maybe it's not. Okay, and FF02. Okay, there is an FF0. So FF0 is correct. There is a choose 2 here, and there is 5 answers, so we need to choose another thing. No and no, definitely not. F000 was for FC was for the unique local for the private, so it's not FC. I'm sorry. I believe this one is mistyped. I believe this one is mistyped. I believe this one is also, yeah, this should be FF02::1. I'm sure that it should be this way. So this will be the other answer. This should have been FF02::1 because these are already known and previously seen IPv6 addresses, and they are definitely not a multicast address. This one is correct, and this one I believe it was mistyped. And let's see if you will see such question in the exam. Okay, so question 12 is about some information, and the answers should be a drag and drop. Refer to the exhibit. Drag and drop the networking parameters from the left onto the correct values on the right. Okay, so there is a show IP route here. What are those informations? Default via 122.168.1.193 dev eth1 protocol static. This is a script. Actually, we haven't seen such scripts in chapter 7. Let's see what we can do. 192.168.1.0/26 dev sth1 proto kernel scope. I believe this is Python programming. Okay, and there is IP address show Ethernet 1. In Ethernet 1 you will find that the MTU of Ethernet 1 is 1500. The QLAN is 1000. This is the MAC address, and this is a broadcast. INET refers to IPv4 address. Good. Let's see, IPv6 is this one. This is a link local. Okay, forever. So the default gateway is, I need to drag the default gateway to its correct. Default gateway will never be MAC address. It might be one of these three. Let's see where the default gateway is mentioned. Default via this one. I believe this one will be the first answer. Okay, a host IP address. A host IP address will be this one, because INET means IPv4 for an interface, which is ETH1. So this one is a host IP address, definitely. An NIC, network interface card, MAC. This is not a NIC MAC. This is a NIC MAC. This is how MAC address looks like. So this is a MAC. An NIC vendor OUI, which is half a MAC. This is a half a MAC. This is getting easy. And the subnet mask will definitely be this, because this is a /26 subnet mask. Okay, so we almost did not use this one, only for this guy. And okay, so in 5 of these questions we have used the exhibit to answer 2 of them, and the other 3 will logically, because this is a MAC, this is half a MAC, which is the vendor OUI, organizationally unique identifier, I believe. And also this one is a MAC subnet mask, which is /26. Oh, this one was easy. Okay, so question 13. Let's hit the pen again. What is the default behavior of a layer 2 switch when a frame with an unknown destination MAC address is received? How many times did I mention that in chapter 2? Once a switch receives a frame and there was no destination MAC address, it was empty, then the destination MAC will be seen as FFFFF, which is unknown, and the behavior will be broadcast. Broadcast means the switch will receive this frame, it doesn't know where to head it or where to forward it to, so it will forward it, definitely will flood it to all the other interfaces in this switch except for the interface that it received it from. So let's see if flooding broadcast, or I'm sorry, frame flooding or broadcast behavior is mentioned here, because possibility number A, or I'm sorry, answer A is layer 2 switch forwards the packet. Who said anything about packet? We are talking about frame. Okay, let's see, consider the same thing. Layer 2 switch will forward the packet and adds the destination MAC address to its table. It's unknown. How will it add it? It's unknown. Okay, B, the layer 2 switch sends a copy of a packet to CPU for destination learning. It's unknown. How will it learn? Oh, okay, as a behavior, no, it will not be the CPU. C, the layer 2 switch flows the packet to all the ports except the receiving port in that VLAN. Yes, finally, thank you. The layer 2 switch drops the received frame. No, definitely not, unless you have like some protection mechanism that we have talked about before in chapter 5. Okay, so question 14 will be, an engineer must configure a /30 subnet between 2 routes. Which usable IP address and subnet mask combination meets this criteria? /30, we can write it in the way of 31s: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 9, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That is 30. Okay, don't go so far, no more. So this is how it should be written. If we convert this one to decimal, all of these will be using chapters 1 method. Is like these are for 8 ones. So the conversion chart will be by typing 1 multiplied by 2 will be 2, multiplied by 2 will be 4, multiplied by 2 will be 8, again 16, 32, 64, 128. Whenever there is a 1, you will consider the number above it. Whenever there is a 1, you will consider the number above it. Again, a 1, consider the 4. Again, 1, consider the 8. And also 16, 32, 64, 128. 28. Combining all these numbers will give you 255. So this one can be rewritten in the decimal language as a 255. This one is similar. This will be 255. This one is similar. This will be 255. And the last one will be 1, 2, 4, 8, 16 up to 128. So only 1 and 2 will not be used like this way. This is 0 and this is 0. So like this is 0 and this is 0. So this will be 4 plus 8 plus 16, and that will give me the result of 252. So what I mean is that subnet mask slash 30 will be written this way. Let's go to the answers, since there is someone who is giving interface Ethernet 00 with a description and an IP address. So number one will be slash 30. This is possible. Okay, number two is using 248. This is not a slash 30 subnet mask. Answer C is using no slash 30, so this is not a possibility, and this one is also a possibility. So let's see what's the difference between them. This is interface Ethernet 00, also this one. This has a description. Okay, this will not affect us because it's asking for a usable IP and a mask. Okay, and the IP here is 10.2.1.3. the IP here is 209.165.201.2. You might say, what's the difference then? Let me just tell you something. Slash 30 gives you 31s and 2 zeros in the end only. By using the equation of 2 up to the numbers of zeros, this means 2 up to the 2, which are 2 zeros here, and that gives me 4. So slash 30 gives me only 4 IP addresses as a total, starting from, like for this network, it will be 10.2.1.0. This is the network ID. 10.2.1.1, this is a usable IP. 10.2.2.2, this is another usable IP. And 10.2, I'm sorry, what are this? 2.1, this one, I'm sorry, 1.1.3, this is the broadcast ID. This is not usable. This is not usable. Only these two are usable. That's why slash 30 is called a point-to-point subnet, because it gives only 2 IP addresses. The question is tricky. Usable IP address, not addresses, a usable IP address. Dot 3 is not usable. It's a broadcast ID. You can never type it inside the router at all. So you are useless. I'm sorry. Also, you are useless. Dot 2 is good because this is also slash 30. So dot 0, 209, 165, 201, dot 0 is an ID, dot 1, dot 2 are usable, dot 2, dot 3 is broadcast. So dot 2 is usable. That's good. Okay. So head with it. Good. Oh, that was good. Okay. Question 15 will be, this is the question and this is my red pen. Which network allows devices to communicate without the need to access the internet? This is like building a private network. How do you build a private network? It's either by using private IP addresses. And how you build an internet network? By buying or purchasing a public IP addresses. So making devices communicate together inside a private network, this will be achieved or done by using private IP addresses. And the range of private IP addresses are the 10.0.0.0/8. Everything 10 is a private. And 172.16.0.0/12, just like we mentioned in chapter 1, is also this one. Okay, just don't get confused. This one, this is chapter 1, and this is IPv4, and IPv4 do have types, and the private IP addresses of IPv4, all the 10s from 172.16 to the end of 172.31.25.255.255, which is 172.16.0/12, and this is the third range. So going back to the question, we just chill. 192.168.0.0/16 is also private. So going back to the questions, the possibilities are possibility number 1, 172.9. No, private start from 16, so 15 and below is public. 172.28. dot 0 dot 0. Yes, because this one is possible. 192.0, no, 192 starts from 1 to 168.0 is below that. This is public. 209 is definitely public. It's away from here. So B is the correct answer. Okay. Question 16. Refer to the exhibit. Which statement explains the config error of this config and the message that was received? The configuration says interface gigabit Ethernet 101. Okay. We have access to the config if, no problem. IP address 192.168.16.143 with this subnet mask. This is 240. 240 is /28. And there was an error saying bad mask for 28 for this address. Why? Maybe this address is not included in the 28 range. Let's see. /28. What are the possibilities? It belongs to a private IP address range? No, 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 no. This is about a mask. It's not about you can use thankful to the CIDR technology, you can use /28 with the 192. The router does not support /28. There is no such router. Maybe in the 80s, 70s, but not now, definitely. It is a network IP address. This is an even number. Whenever you see an even number, I'm sorry, this is an odd number. .143 is an odd number. Whenever you see an odd number, this is a broadcast ID. Whenever you see an even number, it is a network ID. So no, this one is not a network ID because it's odd. It's a broadcast ID. Yeah, maybe, definitely, because it's an odd number and it's refused. So this is a broadcast ID, and you are trying to use a broadcast ID for an interface. This is not accepted. You can use 142, 141, 140. Okay, you have in a range of 14 IP address below that to use since it's /28. I hope that was good. Question 17 says, which IPv6 address type communication between subnets and cannot route to the internet? Back in chapter 1, when I have talked about multiple IPv6 types and how to type a big IPv6 address, I said that it's really complicated, annoying, and a big pain to give a unique IPv6 address to each interface without causing any duplication. So there is a very simple way of generating a unique IPv6 address to each interface by using each interface's MAC address, okay, which is just like I've mentioned a few questions ago, the link local modified EUI64 method. So by using the link local method, you can create a unique IPv6 address to each interface, which is used only for internal communication between the ports. This will not be used for internet. This will not be routed. You need a global IPv6 address for internet. So if there was a link local, and yes, there is a link local, it's definitely the answer. That was good. Okay. Question 18. We are almost reaching 25 questions in this video. That should be very good. Okay, so question 18 will be, where is my, okay, this is red. Which IPv6 address block by block, I mean this range, sends a packet to a group address? One packet to group is a multicast. One packet to one destination is a unicast. One packet to everyone is broadcast, and broadcast is not supported in IPv6, so it's only unicast, anycast, or multicast. This is saying which IPv6 is sending from a single to multi, and that will definitely be the multicast. Multicast we have just talked about a few videos ago. It was not the global, it was not the link local, it was the FF. Was it? Yeah, I believe it was the FF video. Let me see, going back, question I did not. Yes, the FF0 is a multicast IPv6 address. So FFCC is a multicast. It's not an FC. This is a private. This is the FFCC ::/8. You can use class. I'm sorry, question. Oh God, just chill. Okay, you can use this one as a multicast IPv6 address. Okay, that was question number 18. Question 19 will be, chapter 1. Oh, I can see the CSMA. Okay. What are two reasons that cause late collisions to increment on an Ethernet interfaces? More collisions. Okay. A. When CSMA over CD is used. Maybe. B. When one side of the connection is a half duplex. No. This will not even work. When the sending device waits 15 seconds before sending another frame, there is no such device. No, 15 seconds is killing. It's even in microseconds. It's not even in seconds measure to resend frames. When a collision occurs after the 30-second byte of a frame has been transmitted. I'm not sure. I'm not sure really. This will cause some latency in the collision. Or when the cable length limits are exceeded, definitely with the copper cables. When you buy like a Cat5 category 5 copper cable and says that it only supports 100 meters, so you will cut the end and join it and make it extended for 130 meter. This will definitely cause latency in the frame transmitting inside the cable. So this is correct. I'm not sure about this one. Almost sure about the CSMA over CD to prevent collision. So I will choose AE. No, not D, not B and C, definitely not B and C. So I will choose AE. I agree with AE. Okay, and I hope that you do too. Question 20. What is the benefit of using a Cisco wireless LAN controller? Two types of architectures in the chapter 6 that I've talked about before. It's either you have a standalone full access points that each one of them must be accessed individually and configured individually, or you should buy a lightweight access points and make all of them connected to a switch, and this switch will be connected to a controller, and you will only access the controller will controls all those lightweight access points. So what's the benefit of a controller? It eliminates the need to configure each access point individually. Yes. Any other option? Maybe central IP management requires more complex. It's definitely not more complex. It's much more simplified. Unique SSIDs cannot use the same authentication method. Why not? No, I've talked about that in the Wi-Fi security, I believe. It supports autonomous and lightweight APs. No. Controllers do only support lightweight APs, lightweight access points, which are labs. LAPs, autonomous, do not get connected to controllers. Okay, so answer A is the correct one. This is question 20. Question 21. Which action is taken by a switch port enabled for PoE, power over Ethernet, power classification override? If a monitored port exceeds the maximum administrative value for power, the port is shut down. Maybe like if a port should only use 15 watt and it's using like 20, it will get a shutdown. Okay, or when a power device begins drawing power from the PoE switch port, a syslog message is generated. So answer A is to shut down the port. Answer B is not to shut down the port and not to limit the power, but only to generate a syslog. C, as power usage on a PoE switch port is checked, data flow on the connected device is paused. So the port will not get shut down, but data flow will, no, PoE will not affect the power of the data at all. D, if a switch determines that a device is using less than the minimum configured power, it assumes the device has failed and disconnects it. No, actually it will retransmit a lower wattage for the device instead of disabling it. So I will go with A. Okay, so let's take the pen and I will go with A. Shut down the device and make it error disabled. You will need to shut it and unshut it manual then to fix it and re-enable the port later after fixing the problem. Okay, so question number 22. This will be which statement about link aggregation when implementing on a Cisco wireless LAN controller. In chapter 6 we have that. Let me show you that I've talked about like P chapter 6. More details. There was a slide called notes. Positioning. This is modes and there is notes. Yes, this is notes and notes saying to bundle or aggregate ports in a controller, just like the question says. You can use channel group mode on command on the switch because the WLC does not support LAC-P or PAG-P. Okay, good. Let's go back and see if this information is helpful in any way. Okay, the question says, which statement about link aggregation when implementing on a Cisco wireless LAN is true? The Ether channel must be configured in mode active. No, 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 no. I just said that it does not support LAC-P and LAC-P uses active. When enabled, the link aggregation, the WLC bandwidth drops to 500 megabit per second. No. To pass client traffic, two or more ports must be configured. Actually, even if you are enabling bundling and there is only one interface inside the bundle, it will work in routers, switches, and other devices. Enabling LAC-P or bundling or aggregating even in non-Cisco devices, it just requires to have at least one port enabled, and then later in the future you can just add multiple points inside this virtual LAC-P port. So to pass client traffic, two or more ports must be configured. No, one port will be enough, believe me. I've been with that in the devices before. So D, and hopefully D is the correct, if I'm not mistaken, one functional physical port is needed to pass client traffic. Yes, and it's saying functional. By functional, I mean I might already have configured two ports inside the aggregation of the WLC. Maybe one of them failed and went down. Does that mean that the traffic will go down? No, the traffic will keep flowing in the other physical and functional interface until the other failed interface gets fixed and go back operating. So don't worry, having only one interface with LAC-P will work until the other one is fixed. Okay, so which two conditions must be met before SSH can operate normally on a Cisco IOS switch? We did a lab on a switch using SSH, and we have configured all the 6 pre-steps of SSH, and I've also added a default gateway, IP default gateway command in the switch, heading it back to the router, and then from the PC I have accessed the router, the switch remotely using SSH. So there is a lab for that. So I need to choose two, and it's 5 answers. So let's see the two conditions that must be met before SSH can operate. Two conditions must be met before means a prerequisite. A, IP routing must be enabled on the switch. Switch does not support routing. It's a layer 2 switch. A console password must be configured on the switch. No, console is something in the management plane, and passing through another devices is using the data plane. No. Telnet must be disabled on the switch. No, you can enable Telnet and SSH at the same time. The switch must be running a K9 iOS image. Actually, Packtracer did not verify that, but Crypto K9 is for IPsec, I believe. It's not for that. So let me see the other one. The IP domain name command must be configured on the switch. Definitely, that was one of the prerequisites. Since it's choose to, and those are definitely wrong, then I will go with D also, so it will be DE. Okay, so the IP domain command, I did that, but we did not check a version in the iOS image. The iOS image, we did not check that in the Packtracer, and it seems that it does affect. So we will need a minimum of K9 crypto iOS image installed in that inside the switch to be able to run and use SSH. Refer to the exhibit. This is exhibit with some commands. Which password must an engineer use to enter the enable mode? This is enable secret. Okay, so let's see if enable secret is here or enable password. So this will be config T AAA new model. This is some AAA config that was removed before from this CCNA. Line VTY024. Login authentication default. Exit. There is a username and password. This is for entering the device, and there is an enable password and enable secret. There is enable password and there is an enable secret. I believe having two passwords, the other one will override the first one. Why I'm saying that? Because Cisco 123 is here and testing 1234 is here. So which one of them? I believe the other one, the new one, will override the old one. So this will be wrong. Of course, it's not admin or default. So it will be this one. Testing 1234. I will go with this one and I'm sure that it will work. Okay, one last question to finish this video. Okay, this one says refer to the exhibit. Two switches, 802.20q between them, meaning that this port is trunk, this port is trunk, just like we've seen in chapter 2. This is fast Ethernet 0101. Which action do the switches take on the trunk link? Based on the config. Switch 1 says interface fast Ethernet 01 encapsulation.20q, so it's 802.20q. Okay. The native VLAN will be 999. Native VLAN means this is the VLAN that will travel carrying no tag. Okay. Okay, let's see. And switch port mode trunk. Okay, it's trunk. Thank you. The other switch also 01, also encapsulation.20q. And native VLAN is different. Okay, switch port mode trunk. Which action do the switches take for this trunk link? It's not saying about data flooding, saying that after you configure this, what will happen immediately. The trunk does not form. No. Trunk is not related to having a faulty native VLAN. No. A native VLAN will pass through a trunk interface without a tag, just like it's an access interface. It doesn't have a tag. It does not tag a thing, or it removes tags from the VLAN ID inside the frame itself. Okay, so this is not related. Trunk will form. The trunk forms, okay, but the mismatched native VLAN are merged into a single broadcast domain. The trunk do forms, thank you, but the mismatched native VLANs, which are 999 and 99, are merged into a single broadcast domain. We are already in a single broadcast domain. It's switches. Already both of them do operate in a single broadcast domain. Let's see answer C. The trunk forms, okay, but VLAN 99 and 999 are in shutdown state. Actually, these are not interface VLANs to be shut down. These are not layer 3 VLANs, they are layer 2. The trunk does not form. This is not accepted. The trunk will form, so A and D definitely not. 99999 will not be shut down because these are not interface VLAN. These are not layer 3 VLAN. These are layer 2 VLANs. And yes, there is a layer 3 VLAN. Don't hate me. There is a layer 3 VLAN that you will see in the Mega Lab coming video series. Okay, it was removed from the new CC. Actually, it was a part of a subject that was called inter-VLAN routing. You can use either one of two methods, which is either a router on a stick, ROIS, which uses routers and sub-interfaces, or a multi-layer switch with a method called SVI, switch virtual interface, and that is using a layer 3 VLANs, interface VLAN. Okay, so since all of those are incorrect, and then since there is a trunk, okay, there's a single broadcast domain already, so I will go with B. I don't mind that. Okay, so that will be good. Okay, that's it. That should be good for you. What I will do is that this is a blank page. I will just type the answers that I have answered in this question, but I will not type the answers of, I'm sorry, it has been almost 90 minutes. I need to change my seat. Yes, so in this blank page I will only type the answers of these 25 questions. The drag and drop, I will not type its answer because it's all about drag and drop, so you need to watch the video. But just to check with yourself in the end of this video and the end of the slide, just in case you have printed the slide on paper and you want to see the correction, you see that did I do good, and yes you did. Okay, so thanks a lot for watching. I need your comments, your review, your opinion, your suggestion before recording the next video. Having 25 video meaning 25 questions in video, meaning that this series will have from about 4 or 5 videos for preparation, but since that there might be some updates, so this series will keep updating in the future. So this will be the April update, this 100 question of April, and the upcoming videos, or maybe in May, June, July, there will be more videos coming for maybe more questions that you might see in the exam. Okay, so thanks a lot for watching. I hope that you did make some use of this video, and it helped you with understanding the exam nature and the questions also. And I would like to see you in another upcoming video. So thanks again and goodbye.